All right, I am back at it. That is not what we wanted. Test 1, 2, 3. All right, looks like we're good. Let's see where we started off last time. All right, to give you guys a little refresher on where we started, we were making a Solana program, custom in Rust and Anchor, and then we were going to be building a front end for it with React and TypeScript specifically. And I'm trying to remember what we did last time so we can start back off. So the program we are writing this time around is a diamond hands program. So what that is basically we're going to be connecting our Solana wallets to it, and we will choose some sort of asset, NFT, SFTs, or cryptocurrency, just in general, and we set a date. We're good? Yeah, we're all good. We set a date, and then we go ahead and we can redeem it. There we go. So think of this as very much as like baby's first staking program, right? So the only thing we're missing out of the Diamond Hands program is, rewarding tokens out of it, and that's it. And we can probably add that later if that's something you guys want to go through. But for now, it's just going to be Diamond Hands. So very simply, we create a user account. We load up basically our vault with whatever NFT we want, and we set a date to when we can retrieve it back from the program. So I was thinking about a couple things we can do, but let's see what we have started. So I always like to pull up the terminal to see kind of where we're at. All right, so again, we are using Anchor and Rust Anchor for the actual Solana programming, and then we're using TypeScript and React for the front end stuff. But last time we ended where we were able to create some dummy NFTs and then instantiate a Diamond Hands account, and then basically just check that we transferred our NFTs to the actual gatekeeper in the Diamond Hands account. And a gatekeeper is basically just think of it as like a little bot that signs for transactions for a PDA or program-derived address. All right, so we got that. And just for wiggles, we're going to go anchor test, and we should, this should all work because I haven't touched it since last week. I've done no programming on it just to see where we are. So the anchor test is really nice. Right now we are set up to use DevNet. It's a lot faster if you use TestNet. But the reason I like to use DevNet is because that will accurately represent other changes, and you can use other programs that were also deployed on DevNet. So for example, if you wanted Metaplex's NFT metadata, you wouldn't be able to do that on local net because it's running basically a validator on your own computer, and it just doesn't have access to that. It has access to the basics. All right, so all these things, basically that's DevNet signing away. We're uploading our program, and we got our program ID. Perfect. So starting the test, it created the NFTs. It got the gatekeeper vault. And remember, the gatekeeper is part of the actual, I'm trying to think of this. Everything is an account in Solana. So the program we're interacting with is an account. The Diamond Hands program is an account. And think of what we're doing is the Diamond Hands account is, think of it as like an object in object-oriented programming, where when we create it, we have to instantiate what's inside of it for it to work. And one of the first things we do is, okay, well, in this Diamond Hands account, so this is what we're looking at, we have the owner, which is going to be us, and then the gatekeeper, which has a nonce, and then I keep the vault address there just because it's easier to call on the front end. It requires a little bit more to keep, but that's okay. And then of course we have the date1 freeze. So we go ahead and we grab what's called an associate token account, which basically guarantees that we can rederive the address every single time. Because if you think about it, if you just spun up an account or a wallet and you didn't keep a record of that, there'd be no way to remember what that wallet address is unless you had the secret key. Well, the thing is with these PDAs, we don't ever have secret keys with them. That's part of the beauty of them. You only have the public key, and that's derived especially from associated token addresses. So that's not entirely true. The gatekeeper itself, which is a different account altogether, it's the authority that signs for token exchanges. We get that by doing find program address. We give it our Diamond Hands account, DHA, and we use that basically as a key, and it returns what's basically called a nonce. So when it finds a valid address, it returns that, and we are guaranteed that that is going to be the same. The gatekeeper can always be rederived from the DHA. And same with the associated token address. So this is basically the derived address from the gatekeeper for basically a token account, which is what can hold NFTs and any other SPL tokens. So we need to do that, and we derive it this way. And again, I'm just spewing out everything just so people hopefully have enough to chew on, and you can of course ask questions. And if something doesn't make sense, or you're like, come on, coach, you're rambling too much, you can call me out on that too. All right, so then we call create Diamond Hands account. This is where we're actually building the account. This is where we reserve space on the blockchain and basically instantiate the account, which think of accounts as just classes or objects in object-oriented programming, except the memory is living on the blockchain. All right, so we have our accounts, Diamond Hands, gatekeeper, vault owner, and vault owner, that's going to be, so owner is us, we're the ones who are paying for the space, and vault owner, that is our associate token address for the NFT the dummy NFT we just created. So we got the token program and then the system program. We need the system program to be able to pay rent, and that's going to be part of the in the actual lib. You need to pass in the system program anytime you're doing an init call, because this init call, like this is why Anchor is super awesome, is because you can put on these macros and basically it will do all those checks for you and call the initial or the buy rent space for this particular struct. So that's pretty sweet. All right, so we got that. Just log it out, fetch, and what we can see is that our gatekeeper, our owner's NFT count, which is our vault, we had transferred our one NFT to the gatekeeper. So we basically just verified that the gatekeeper does own the NFT. So, all right, what else do we need in this? I think we should start back at the Rust end of things. So create the Diamond Hands account, and we'll just run through this again. DHA, this is our structure, and then current date. This is the date, what it is now. Do some checks, check that the gatekeeper is okay. There's no logic really in this call. It's pretty standard. It's a pretty standard constructor. Once we check all those things, we want to transfer our NFT from our owner's vault into the gatekeeper's vault, and that's what this block of code does. Then we have the token TX, and then we check to make sure everything's okay there, and then we just set this last little thing. So what else do we need to do here, eh? All right, so I think the next thing, what would make sense, is we're going to make another function, and I like to copy and paste as much as I can. And this one's going to be called, I don't think we have to do anything other than just retrieve the NFT. So what should we call this? I'm going to have to, this is my one complaint. I know there's options out there for a spell check on VS Code, but I'm going to have to Google how to spell retrieve. All right. Retrieve assets. Yeah, we'll go assets. All right. And then I always like to do the same naming convention for the params. It just kind of keeps everything clean, easy. It's a little verbose, but I tend to program more verbosely just because it's going to help me remember. And if I ever, I'll release this code out to the GitHub. But it helps me remember, and hopefully other people reading it like, oh, that's what that means. So retrieve asset params, we go down here, we change it to that, and I don't actually think we need anything. So that might just be an empty struct. All right, so this is where we see a little bit more magic from Anchor here, is we can basically guarantee that this Diamond Hands account is owned by us, the owner, the person who's calling it back. So we're going to do that. It's a mutt, and mutt in Rust just means you can mutate it, you can change it, which is really interesting. I think that's why it's a decent language for blockchain, because everything by default is like a constant, like you can't change it, or final if you're familiar with that. You actually have to put, let mutt, variable equals X to be able to change it. So I think that's kind of a neat paradigm. Okay, so we're going to do has one, and we're going to do that equals the owner. So what this is a super sweet little thing. Let me see if I can grab the docs for it, because it's these things that make Anchor so powerful. Is one, it completely simplifies what needs to be called. Like, you don't have to worry about entry points. You don't need to worry about all these checks that you have to do, because a lot of that is just built into these macros that you see here. And if you're ever familiar, I'll post this link, because it's a great place to look at the Anchor things to see what's there. And there's a lot. Anchor has one. Has one. All right. Yeah. And this is also a really nice piece of information as well, is the actual Rust documentation. I'm most of my career has been C programming. I do a lot of embedded systems before I got into um, crypto stuff. And Rust and C are very similar considering they're both, you have to manage your own memory. Um, they're both quite a bit lower level than, other ones. Um, and the syntax is relatively similar, but what's really, really nice about Rust is the documentation. Like it is phenomenal compared to C, and that's super helpful. Okay, here, this is what I was doing. Trying to remember. But account has one target. Checks the target field of the account matches the target field in the struct deriving accounts. So basically, it's saying um, the owner of the Diamond Hands account of this structure is the owner, and that's what that verifies. Um, Even on top of that, I like to overkill, and we always do constraints. Yeah, constraint. And I still like to do diamond hands dot owner equals um, owner dot key, because the diamond hands dot owner is this variable right here. If I change that to uh, diamond hands man, I would have to change it up here. So owner isn't like an inherent property on this structure. It's just what I chose to name it. Anything else we need to do? So what we could do here, if we really wanted to, and this is why it's also kind of cool, we can do diamond hands dot date to unfreeze. Here we are, dot date to unfreeze, and we need to make sure that that would be less than, let's see, this is how you can tell. All right. So we can do this check here where we're basically saying is the date time to unfreeze, and to keep with the naming convention, we're just going to call it unfreeze asset param. I have a little bit of OCD. All right. There we go. I had it right the first time. All right. So on to my point. We can do diamond hands.date to unfreeze, and we want to basically check that that the current time in Unix time is larger than this date to unfreeze, because obviously if the date is later, we'll be able to unfreeze it. But the reason I don't do this is because if you were to fail out on this and like call this unfreeze assets from the front end, the error message you would get is I think it's a raw constraint was violated, which doesn't really give you a whole lot of information. So I like to do this type of checking in the function itself. But I do like to do all of the owner checking and making sure who owns what right here in the actual headers. So we need the gatekeeper, and this one's a little bit interesting because we can do something else now that we have it derived and initiated, and we can. Give me 1 second. File. Open console. Save. And we go to gatekeeper. here we are. So basically we can have this header where we go seeds, and this is like I was talking about at the very beginning, we rederive the address for the gatekeeper itself, because the gatekeeper should be tied to the actual account, this data account of Diamond Hands. And that's exactly how this works. So what we do is we put the seed is, the seed can be any like array or amount of bytes. Um, it just helps. I'm sure there's actually a max length to how long your seed phrase can be. But for our point being, it's just going to be basically the key of this Diamond Hands. And what I could actually do as well is I wouldn't even have to do that. I could do Diamond Hands dot. I believe I save itself. I do not in the Diamond Hands account. Sometimes I'll do pub Diamond Hands and put the pub key and basically just keep a reference to itself in here. But we don't need to do that. It's not a terrible idea too. We're going to. Why not? Pub Diamond Hands. Pub key. And we'll call it Diamond Hands count. Oh, also, I forget, I was just doing a bunch of TypeScript stuff. Diamond Hands account, we do snake case and Rust. All right, so Diamond Hands account, and this is 100% just to make a point, because we're going to go back to what it was. But we can do Diamond Hands account dot to ref, I believe it was. And that's going to be the same thing. Will it though? Seeds Diamond Hands dot to count info dot key dot as ref. Right? Oh, no, it's going to be a little bit different. But anyway, we're going to keep that. The seed is the same. It's the actual address of this Diamond Hands. And we can go bump. And this is going to be Diamond Hands.nonce, which we saved when we created this thing. All right, so we got our gatekeeper. Great. Another thing we can do here is if we really wanted to, this is redundant. And I think we can do it, is we could do constraint equals gatekeeper dot key equals Diamond Hands dot gatekeeper. Does that work? Yeah. So the other reason I keep references to what is what, it makes it easier to call on the front end, and it also gives us that piece of information to be available for checks in the actual function setup here. So we don't need to do this because this is redundant, because if we did it right, and we'll keep it just because we can, but if we did this right, this Diamond Hands that to account info, this basically checks and derives that this is valid for this account. So, or this basically checks to make sure that what we pass in for gatekeeper is equal to the seed bump combo. All right, vault. We can actually keep all these pretty much the same. We still have to be the owner. Oh, and was I putting all this in the wrong one? I was. We're going to put it here. So we got gatekeeper, and we can keep, like I said, most of this the same because we need the exact same accounts to draw it out then as we put it in. So that's actually going to be really nice. So unfreeze assets. So now we basically just have to do the reverse of the creation. So do that. And now we're going to do unfreeze, freeze assets. All right. So freeze assets and then unfreeze assets param. We don't actually pass anything through here, so we don't really need it, and we're just going to take it out. You know what? No, we're going to make it just a little bit more sophisticated. Because what happens if we use like an SFT, a semi-fungible token, and there's multiple of them, or we're actually just pulling a token. So what we're going to do here is we're going to do amount, and I think that's what we did here, yeah. So let's say we wanted to take out only one of the token, right? And then we could pull out the rest later and just keep it as like an extra wallet laying around somewhere. 100% not necessary, but may as well just throw it in there. All right. Oh, and another kind of fun thing here is what we could do here is we could also fail it right away. So we could also say vault dot amount is less than 1. So basically, if the amount is the amount would have to be bigger than 0. There we go. So basically, if there's nothing in this vault, fail it. But again, I like to do these checks in the actual function because then I can return an appropriate error message as opposed to just a raw constraint was violated. So we go vault, owner vault, same thing. Yeah, exact same, but just in reverse. So we're going to keep this DHA, current date, those are all important. And we'll go through and clean up the error codes in a second, but let's write the rest of this. So CTX, the amount, we don't care if the owner vault has any, so this is just going to be vault. So we need to make sure that the vault still has some amount. And it has to be if the amount is less than the amount, we fail it. And if current date is, of course, less than, and this is going to be DHA dot time date to unfreeze. Oh, man, I'm fumbling the ball today. All right. Probably doesn't help that I've been coding since 8 a.m. today and it's 6 p.m. now. All right. So the current date is less than. So basically, if there's still time left to unfreeze, we're going to fail it because we don't want to pull it out until then. Is there anything else we need to check? I don't believe so. We don't need to do the gatekeeper check anymore because we've already did it in its creation, and we already basically that's what this section does here too, is it does that check as well, and we're just going to get rid of that to clean it up. All right, simple checks. Now we just do the transfer. And like this transfer is a little bit different here. And this is why you're going to see why we have the gatekeeper. Because we can't solve or we can't sign for the account, the Diamond Hands account, to transfer its tokens back to us. Because if we could sign for that, right, you know, it would technically still be our account that we had access to the private keys, and then we could do whatever we wanted to anyway. So the gatekeeper is, of course, the authority. And how this looks different is we have this. Is basically we have the seeds, which is just like the seeds we are deriving from right here. It's the same seeds. And this allows us to basically sign for the vault to transfer the tokens back to us. And of course, this isn't a game. I pulled these things out from my other programs just to make it a little bit nicer, and so I remember what I'm doing and have a decent startup for the actual stream, so I'm not taking forever retyping it all. So DHH account information, key as ref, yep. And then we have the nonce, of course. So signer is just the seeds. And then we have the CPI program, cross program invocation. That's what CPI stands for. And we're basically using the token program, which is its own Solana program, to actually do our transfers for us. So that's pretty exciting. We got to transfer from vault to owner vault. And then the authority, of course, is our gatekeeper, and that's what this seeds is rederiving. So think of this as almost the gatekeeper's private keys, although it's not quite the same. And then we have CPI context new. Oh, right, it's just transfer because we already have token. So now output TX results, output CPI, and then we do our params dot amount as U64. It's already a U64, correct? Amount, yep. And then basically just check if it's okay. We will go through and do all of these errors in a second. And then what we do is we don't have to change that ever. What we could do here if we really wanted to, and we're going to, just because I think it's a decent idea and it only costs a little bit, is basically put a flag to see if it's been cashed out. Cashed out or unfroze. We'll keep the same, and that's just going to be a bool. The bool, of course, is the same size of a byte. Bytes and bools and chars. I don't know if there's chars in Rust. Is there? Yeah. They're all just a 1 byte length thing. And we also have to update our size here because we added in the Diamond Hands account under the owner, and then we also have a 1 date to unfreeze, and then we have a 1 because 1 byte for unfrozen. How about that? Thawed. I like that better anyway. And again, I use fun naming conventions, and I know my idea of what's fun is probably quite funny to some people. but I use fun naming conventions as opposed to boring ones because I think it's important to almost tell a story with your variables and be able to relate them so people can kind of intuitively understand what's happening. Um, like when they're calling something, obviously unfreeze would mean, I can get to whatever's inside of the thing. And when something is thawed, of course, there's no more ice. And it assumes that it was, frozen in the first place. DHA dot thawed equals true. And that's actually not quite true yet either. And we don't actually do all those. So one thing we have to do is we need to update it here. This is in our creation DHA dot thawed equals false, right? Because when we freeze it, it is not thawed. No, I'm not going to go into that. I was thinking about renaming all of this to freeze assets to keep with the naming convention, but these are the types of things I run into where I'll think of a better naming convention, and sometimes I just need to let that go. DHA thawed, and we don't want to put this to true right away because what happens if we don't pull out the entire amount that's in that account? So what we can do, and we can also do this, if accounts dot, we're not going to do that there, we're going to do that here. So these two should never matter, but just to show, you wouldn't ever need these two because emptying out the vault account, as you'll see, will set that flag. But we're going to just be redundant just to hit this from every angle we can. DHA dot thawed. So basically, if it's already been thawed, we're going to throw an error. And doesn't really matter in which order you put it. I'll just put it there. I like things to visually look good, and I usually go for descending or ascending, if that makes sense. DHA thawed. So we're not actually going to do this yet because what we need to check is if params dot amount is less than our vault amount, right? So if we pulled less than the amount that's in the actual vault, it's not completely frozen, or it's not completely pulled out or cashed out. So, and see, this is where the naming convention screws up again because cashed out would make more sense in this context, but we're not going to change it anymore. So DHA thawed. So if the amount is less than what's in the vault, actually, it's only going to be true if it's equal to what's in the amount because then we would have pulled the rest of it. And the reason this is always going to be true is because we only ever put the amount in the vault that we're allowed to take out, if that makes sense. Like there will never be residual left over. So thawed equals true, and that's the only time we'll do a state change. And there really is no logic here that we have to look out for. So with that, this program, I believe, is actually done. Look at that, how crazy. Little pro tip for you guys: if you're like me and you kind of structure things this way, I go through and when I'm writing the program, I usually do the whole program in bulk. I'll go in and write the TS interface, and then I'll start testing and breaking things. And then I'm very much into iterative design, where I'll keep kind of going back and forth until it all works. And part of that is I know during testing I like to have these errors set, but they're kind of a pain in the butt. So I like to do it all in bulk. And what I do is I actually just pull up another instance of this, and we'll make that a little bit smaller. General error. So now I just go one by one where we have an error code, and then I'll figure out something for it. And I'm not overly crazy about naming these things. It's just, just something to give you some sort of feedback when you're actually debugging. All right, so this one is if the amount is less than the amount, so I use not enough tokens. Not enough tokens in the owner's vault. And then I do that. So stick with me here. This next one is going to be freeze, min freeze time. Okay, so it's less than that, so this is going to be freeze time to short. And interesting, these are the camel cases. So you need to freeze for at least 100 hours, because that's what we defined up here. All right, 2 done. See, this is why I like to save these all kind of to the end, because going back and forth to do all these codes is kind of a headache when you're building it, when you're not really worried about doing the print statements right away. So this one's, we're going to do bad gatekeeper. Yeah. The gatekeeper seed nonce does not match. Gatekeeper. And then this one, so if they're kind of generic errors, I like to keep them up front. And then I separate the errors by function. And this one we're going to be using again, and I just call this could not tx, could not transfer. Tokens from the vault. There's some sort of error, because if it gets this far, it's kind of up to the blockchain to fail or not fail. And then state change, there's no errors here. All right, great. And just to show could not tx, we're just going to put it right there right away. And then we only have 3 more of these to do. And this is going to be unfreeze. All right. So this is saying not enough tokens again. In account. The All right, not enough tokens in account. Current date, basically still frozen. The assets are still frozen. That's what that's saying, because if the date is less than the time to unfreeze, we do that, the current date. Then thawed is already thawed. The assets have already been thawed and retrieved. And I probably spelled that wrong again too. All right, well, I'm not paid for my spelling. So there we go. That's really all there is to this program. Just to give you a little bit more information here, so we can kind of verify and figure out why this is safe. So, and because when I was first learning, there was a decent amount of like mental gymnastics I did to like figure out in my head and convince myself that these programs are actually safe and we're covering all of our bases. So with the diamond hands, so this init means we are going to be creating and allocating space for this diamond hands account. And this diamond hands account is a data account of this size, and it has these information. It's like in C, or I guess in Rust, where you pre-allocate some amount of space memory to store variables. But this time we're storing the variables on the blockchain, which is pretty sweet. All right. So this part is just tuition. So payer is owner. Again, this is why Anchor is phenomenal. So we're basically saying owner is the signer, and this is important. This is signer versus account info. This basically guarantees that whoever this account is needs to also provide their access of signing it, whether that be their their private keys or their provider wallet, whatever that is. Because if I just did account info, well, we'll see that in a second because there's a more pertinent example. But basically, this is saying like, yeah, we need to guarantee that owner is a signer, and we'll see that when we get to the front end. Token program and system program. Again, these are just the programs we use. This is used for the init, and this is used for the CPI of actually transferring the token. So for this vault, it's these constraints that are key. So we're basically saying like, okay, we need to make sure that this vault's owner and token accounts have in the structure itself, because think of a token account just as another data account. They have a field called owner, and we just want to make sure that the gatekeeper is that owner. And that happens when we actually create the token account, which we do on the front end. We can also do it in the back end, but trust me, it's easier to do it back here. Oh, and also this token account, basically, if it's not a token account, this is going to fail too. So like it really is making sure that these are basically guaranteeing what you're throwing at it are going to be the results. So vault owner equals gatekeep owner, or gatekeeper.key. And then we do this associate token address. We don't necessarily have to do this for gatekeeper. We could just give it really any address. I like to keep it get associate token address just to keep it all similar and to be able to rederive it. But since we actually keep this vault pub key here, we actually never really have to rederive it. I just do. I think it's a decent it's a decent practice to use associate token addresses when you can. Okay, so we got the vault. And here's where the majority of the checking comes in. So obviously the owner vault, that's our vault, that's where our NFT actually lives. Every different token, every NFT lives in a token account. And this is the owner equals owner.key, that's us, good. Owner vault equals, or owner vault mint equals vault.mint. So the thing is like to create an NFT or any sort of SPL, you need to create the actual token, and that's where the mint comes in. Like that is like the actual information of the new token that you are creating, and anyone who holds that token needs a token account to house that information. So the mint is like the parent, and then I mean the mint is very much just like saying, I have let's say like a euro, like that's the currency or the token, and then the token account is like the wallet, and the token account can only hold the type of currency or mint that it is designed for. So we do owner vault.mint equals vault.mint to basically assure that both of these are of the same mint or of the same currency. You only have to do this once because obviously that would be redundant. Or maybe it's not obvious, but if you think about it, it gets redundant. And of course, we do our associate token address, and this is just so we can rederive things. Like when you use SPL token accounts, what they give you, like when you do create an account for a specific mint with SPL, these are actually all just associate token addresses. So like that's the default. And if you didn't use associate token address, either you'd have to remember how to rederive it yourself, or you have to keep track of that token account address. There's nothing to say that it has to be an associate token account, but this makes things infinitely better. And yeah, we basically just check that it's the right address. And then again, here's the important part that I kind of wanted to bring up is we have owner as signer. And this is interesting because if we just did, owner account info, no, this isn't what we were looking at. We want to go down here. So we do the exact same things for the unfreeze. Constraint has one owner. That's basically saying like, okay, the person who made Diamond Hands or has like authority over Diamond Hands is owner. Great. And then constraint, Diamond Hands owner equals owner key. Again, a little redundant. I just like to have it in there, cover my bases. Gatekeeper, what the seeds and this bump does is it basically derives this address for us and basically checks that these are the same, like what we pass in and this derivation equals the same thing. If it doesn't, it will throw an error. Vault, again, these are the exact same checks we just saw before. Now here's where it gets interesting. So if we were just owner and we did, account info, so now we're basically saying like, okay, you don't have to be a signer. Fine. The thing is we're still checking that this Diamond Hands account is owned by this owner. So like this would technically be fine. But if you didn't do these checks, right? Then anyone could put in their own public key and cash out whatever in the vault. And that's why these checks are so important to do and kind of like really go over and make sure you're covering your bases. Because if I didn't have this as signer and I didn't have these checks, I could put in any address and it would go to that account because, the gatekeeper is doing the signing. So the gatekeeper doesn't care who it's sending it to. Um, they just know. Because I use the owner vault here. And of course, that's just what we pass in. So that's why it's so important to like make sure you know like what type of checks you're doing, because that would be disastrous. Now, if you had signer, that pretty much that doesn't even necessarily cover your bases either, because without this check, you could put any owner as a signer, um, but it's with this actually is what makes it or breaks it. So we're basically saying like, hey, this is what we need it to be. And the other thing we can do, like in terms of just covering all of our bases, is we can do vault.key equals diamond hands dot vault, right? And this is kind of the other reason I like to have self-references, is because it makes these checks easy. And sometimes you actually need these things to do those checks, but this we don't actually need, but we'll keep it in there, right? The more bulletproof you can make it, the better. But of course, the more bulletproof you make it, the larger the footprint of the program is. But I think it's definitely worth it. I would rather be safe than sorry when it comes to handling money. All right. So we're just going to go back to our front end stuff, because this is officially done. I'm sure we'll find some bugs, but the actual program itself should all work. So we're going to go TS node anchor deploy. So that basically builds and deploys it for us. And while that's working and spinning up, we're going to go to TS. And like I said, I like to, oh, I haven't done anything on this end. I'm not going to today. We can go over building out what a good kind of like an API wrapper would look like, because I think that's really important. Like if you want people to use your programs, which I imagine that's why you want to build them in the first place, you really want to make it as easy as possible for people to actually spin up an instance of your program and use it. So we're going to go to tests, because we've been just doing everything here. And we're going to basically, all right, so gatekeepers NFT count, and we're going to use these same exact things. And this is also part of writing a good API, is you can make functions like this basically just spit out and do those checks or those prints out for you. But the other thing that we do is, I don't think I've done it yet, and we're not going to until next time. I think I'm going to get this thing to test out and work. And then I think next time we'll come back and write out the API and then put a little front end to it, so we can actually see this whole thing in order. And just a forewarning, when we do get to that front end stuff, I am not a graphic designer, so you'll have to be okay with baby's first website. All right. So now that we have this program account diamond hands fetch, this is how we get our account. We're actually going to be running basically another function, and this function is going to be, we can always see what the functions are called if we go to the target deploy or target IDL diamond-hands.json. So this IDL is super helpful. This is basically how we interface with our Rust programs. And next time I'll take you through actually uploading and creating an anchor account on the Solana blockchain to be able to pull this from anywhere. So you don't actually have to use the file ever. Like this metadata or information is stored on the blockchain, and that's super helpful. But this is our new function we're going to be using. I always like to put them right next to it so I can kind of figure out what I'm doing, because when you're using an IDL like this, you don't get the same type of autocomplete you might be expecting. And we're going to go ahead and we're just going to erase all of this and go through one by one. All right. So this is the basic structure, program, RPC, and then this is our new function, unfreeze assets. And the first thing we look at is this, it goes params, and then this is like the object of the accounts, signers, and instructions. So we're going to go ahead and go to the params, and the params, if this was just a number, you wouldn't have these, but since I make it like a type, an object, we actually have to do this. And this is interesting because it says unfreeze assets params, but doesn't look like anything. Oh wait, no, because that's an object. There we go. Yeah, so it's an object, and then we have our amount, and then we have our U64, which if we remember from last time is what we call a big number. And here's where it's kind of interesting. What we can do is, of course, we can just put 1 because that's how we know how much we had put in there. But there's another more interesting way to actually get the amount of information in this account. So 1, we could have stored the count of how many tokens were in the Diamond Hands account by putting pub token, or just amount would work. Make it a U64. But this is relatively redundant information, and we don't need it. I try not to keep redundant information that I can pretty easily derive from the front end. It depends on the use case. This, we're just going to keep it simple, because what we can do is we can, in our Sol helpers, and this is something I've written just to make things a little bit easier, we're going to not get the provider, get SPL account. So this is basically doing the same thing as SPL accounts, SPL token accounts. So this function that we're going to be calling here, oh, we're already doing it here. Wouldn't you know? So let's break this out a little bit. We're going to do owner vault, because I don't believe I have that. I do not. Interesting. All right. Owner vault is going to be this. And of course, we could break this out into another function, and we're going to do that just because it's going to annoy me if I don't. Const get vault info equals async. And we're just going to yoink this. No, that's redundant. We're not going to do it. All right. Let owner vault equal this. So this is giving us the entire vault vault, and we're going to do let diamond hand gatekeeper vault equal the same thing, but we're going to be using nft.address. Yeah, nft.address, and then this is going to be gatekeeper vault. There we go. All right. Yeah, that was what we need. I could have just looked there. And if we do this, it's going to be owner vault.amount dot to number, because the amount is, yeah, that just makes it a little bit readable, a little bit more readable. And then we have this, and this is going to be gatekeeper vault. I'm splitting it out just so we can kind of reuse these variables, because the entire point of what I wanted to get to is that we can do gatekeeper vault dot amount. So this would mean we are grabbing the rest of whatever's in this Diamond Hands account. And that is the only thing for this guy. That's all we need. So in accounts, unfreeze params, and now we actually look at the accounts. And like, this is why the copy paste is so nice, because you can just do that. So it's almost like there's that auto completion. Diamond Hands, which we still have from up here, Diamond Hands dot public key. And this is interesting. So the question could always be, you know, we created this Diamond Hands key pair, right? This generation. And what we would have to do as like a user is we would have to keep track of this key ourselves. But I guess what we'll do next time is we can actually make a way to derive this address, so we can call it just using our own provider key, and maybe we'll get to that today. DHA public key, and then gatekeeper is going to be it's just going to be gatekeeper, I believe. Then vault, it's going to be vault. And actually, you know, why make this harder on ourselves? We know it's the exact same accounts as before, so we're just going to use the same ones. Now, instructions, we don't actually have to do anything different this time, because we're not actually creating any more accounts. We're just pulling out. And we can actually just delete this entire line, but I'll keep it. And here's the thing. So we said that in our lib that owner is a signer. So you'd think you'd have to put owner there, but what's interesting is when you do this program, and program actually has your, like, to create the program, you actually, Diamond Hands is, when you actually instantiate a program, oh, haha, we do the fetch IDL. I forgot that we went over that last time. So good thing to note is we do anchor or IDL upgrade file path target IDL, and that. So we're actually pulling the IDL from the blockchain, actually, which is kind of fun. Oh, and that's why we're using DevNet, because this, if we're going to be using this, why am I not calling that program? Fetch IDL. Oh, because I'm not actually creating the program itself. Yeah, we'll go over that next time. Because we have the program here, but the program uses this IDL, which is this file right here. But since we're just testing and we're not fully fleshing it all out yet, we'll just use this guy. So we go with DHA, webkey, and again, I'm just going to make a comment because we'll do this next time too. Derive it from an address from the layers address. And we'll talk about the pros and cons of doing this in a second, because there's some interesting pros and cons here. All right, so signer. Oh, now to get back to what I was talking about, the reason you don't actually have to put yourself as a signer here is because the program, the way that's instantiated, it actually uses your provider. So it handles all the signing for you. So these are like additional signers, if that makes sense. All right, unfreeze assets. There we go. And then we're going to do this whole thing again. And see if we got our tokens back. And I wonder if you can figure it out now, but this is going to fail. And I'll let you see if you can figure it out before that happens. So we're going to go anchor test. And now it's going to spin up. And I'm going to look at file open. Soul helpers. No, this is going to be coin flip. Get program. So yeah, that's going to take a quick sec, and we're just going to throw this in there real quick. So just to talk about this IDL stuff, as that's running, get program, we pass it the provider. So we're actually just going to switch this up and not do that anymore. So we're going to do get program, and if you figured out why that failed, good job on you. Wait, get program, and then we give it our provider, and then our program ID, which is, of course, our import all as diamond from ts diamond hands. There we go. Diamond hands ID. All right. So what this does is it does anchor.program fetch IDL. So it's basically fetching the IDL that we updated, and the IDL is this, but just put on the blockchain. So it fetches that, and then it creates a new program from the IDL, and then it takes the provider as a variable. And this is actually what does the signing. And so if we look into the provider a little bit, we can go to wallet. And then of course it doesn't give us our private key, because if you had your Solana wallet and you could just print out the private key, it wouldn't work. So good luck with that. But what you can do is do sign all transactions or sign transactions. And what that does is it basically, goes to whatever authority. If it's Phantom, then you press accept, or if you just give it a key pair, it's assuming that it's accepted. And that's basically what's happening in the background when you call. I wonder if this will give us it. No. It will sign the transaction for you. So that's why you don't actually have to put it as a signer. All right. So yeah, we kind of expected this to be the case. The assets are still frozen because obviously when we froze the assets, we had made it into, let's see, 200 hours. So we're just going to do it to where it's only going to take a second. And of course, we're going to run into, we'll make it 5 seconds. Then, yep, is that correct? Yeah. Make it 10 seconds, just in case. And then what we're going to have to do is, before we call that, we're going to do await set timeout. I don't know if that's how that works. So we're going to just do this. Set timeout, and then this is going to be for 500 milliseconds. It shouldn't take that long. And we're going to go ahead and trying to think if that will work. Const sleep equals async. No, it's not async. ms milliseconds number. All right, and we're going to do return new promise. And let's see. Resolve. And then reject. And we're basically just going to do set timeout. And for those who are probably much better at JavaScript than I am, you're probably like, oh no, coach, what are you doing? I'm sure there's a better way of doing this. This is just a way I know how. Callback is going to be this. Resolve. Right. All right, so basically we're gonna wait for that promise to resolve, and that should do what we want it to. So 10,500 milliseconds, so 10.5 seconds. All right, and the last thing we're going to need to do then is take this min freeze time just for testing purposes and make it a 0. And then we should be able to just call anchor test, and it should work because we don't have to actually update our IDL. And if it does what I think it's going to and work, we should see gatekeeper's NFT count go to 0 and owner's NFT count go to 1. And then we'll fix this, and then we'll just go over quickly kind of best use case scenario. Actually, we could probably do that pretty nifty like now that I'm thinking about it. So the issue we have, okay, starting test. We'll see how that goes. The issue we have with this is going to be a relatively big issue, and I'll tell you why. I just want to see if this thing succeeds. That'd be pretty neat. So it's counting, it's waiting right now. Let's see, did it work? Owner's NFT count 1, gatekeeper's NFT count 0. We did it. All right, go team. Calling create, sleeping. And thawing. Neat. Okay, so that worked. We're going to change this back to 100 hours. And it's going to fail every time now, and that's okay. And actually, this isn't necessarily a good thing to have either, forcing people to do that. Like, what happens if they, we'll keep it. We'll keep it. Okay, so that's that. It worked. We had made an account. We waited. We diamond handsed our asset, our NFT that we made, and then we thought it out. Pretty crazy. But here's why this is an issue, and this will be the last thing we cover today. Okay, so you have this DHA, and we basically just generate a key pair. And if you're spinning up kind of a new program, that's not a terrible thing, and then you just keep that key hidden somewhere and use it kind of like a wallet where you can recall it. Or if you have like a site and you have a specific, address you want. So for example, if I had like a raffle account, I was doing a raffle program, as the raffle owner, I would want to generate a key pair and then on the website, just give them the public key so I can re-pull that raffle down each time. But what's interesting here is we can't necessarily do that. Like, we can task the user to hold on to their new generated key and say like, hey, this is where you get it from. But that's not a good solution because what happens if they lose it? Well, there are ways of getting this information back, but it's not fun. A much better solution would be to actually just derive an account that anytime they log in and pass certain arguments, it automatically figures out what that key is without them having to remember it. So it's that derivation is really interesting because it basically bypasses the need to store like this information in a database, which is kind of what we're trying to avoid anyway. So how could we derive that? And to do that, we're going to pull a little something from a coin flip program that I had made for the Soul Ape guys to actually be able to derive a different account. I want to see how I did that. Find Flipper account. There we go. That's what we wanted. And this is, we're just going to start and put this right into our, not Diamond Hands, JSON TS. So this is going to be one of the first things is basically just create a function that allows us to rederive, find export const find Diamond Hands account equals async arrows. All right, so what we're going to do is we're going to create a way to derive this Diamond Hands account from the actual user wallet. So we're going to go ahead and put in, owner, and this is going to be a public anchor.web3.public key. All right. So we don't need that. We're going to return this owner is going to be so this owner, we're going to derive the address from the owner itself, and that's just to buffer. And then this is going to be Diamond Hands ID. Okay, so what we can do now is we can go to index our tests, and now instead of this, we can do, I think it's diamond equals diamond dot await, right? Diamonds. And then here we're going to put provider dot wallet dot public key. Okay, this is great. So now what we can do is this DHA to buffer our index Diamond Hands TS. Is that a promise? Oh, right. So what's interesting now is, again, anytime we rederive something, especially with a program address, like it's not guaranteed to fall on the curve that we need it to in terms of like a valid wallet address. So what we have to do is soul helpers, no, test, there we go. This is actually that, and this is going to be a nonce, or I guess we can call it a bump. We're going to call it a nonce though. We're going to call it DHA nonce. All right. So we got our public key and our nonce, which is great. This is what we wanted. But here's the issue. One, oh boy, what happened here? Oh, right. DHA is now just a public key. Is there anything else that it's yelling at me for? What are you yelling at me for? Signers? Okay. Didn't like public key as a signer. So that is one issue, is now the DHA can't be signed in for a signer. And I don't know if that's necessarily an issue, actually. And if it is, I know a way to fix it. But here's the other thing, is we also need to keep track of this. No, we don't need to keep track of that nonce, not necessarily. But we're going to anyway. And we're going to do pub diamond and nonce. So this is one of the more, I guess it's not necessarily advanced, but like this is where the programming becomes a little bit useful, I guess is probably the best way. Like this is where it actually gets useful, is, you know, how can we make sure anytime they sign in or connect their wallet that we can like pull up whatever they want to see. And we can now go into this, and when we create this, we're going to have a diamond and nonce as well. And then lastly, we have to update oh, we never did this here either. Diamond hands account equals owner diamond hands. Actually, I think it's just DHA dot key. There we go. And then DHA dot nonce, diamond hands nonce equals params dot diamond hands nonce. All right, we got all that. Now, this being said, there's one extra check I like to do. And since we do this check on the gatekeeper, we may as well do it on the DHA as well. DHA address, we'll call it. At DHA address. So create program address, which is the same thing we're calling here, find program address. And we need to match these together. So this is going to be params.diamondhandsnonce, and this is going to be owner to account address, because the owner is who this is going to be. So this is ctx dot accounts dot owner. Right, there we go. All right, so this should do the same thing. This is basically just checking that, hey, this derivation is the same as this, because we want to keep it standard across the board. And this can't be gatekeeper. This should be DHA dot key. So if the address does not equal that, we throw an error. And we should actually change this up to bad DHA address. DHA. Go up and do that here. All right. Do that all, and you'll see why we want to do that in a second. So this is great. We're going to go ahead and do anchor deploy. And then this will be the very last thing we do. And I'll just spoil the surprise for you. This is an okay option, but the reason we don't want just this is because, okay, we derive it just from their account address, but that means they would need to use a new wallet for each Diamond Hands account that they had. Well, what happens if, you want to have several Diamond Hand account per one wallet? So what you'd actually probably want to do is you can do this off of, any number of other ways to go. But you can, I'm also going to base it off of the mint of the token we're doing. Now that this is running, we're going to go ahead and update the IDL as well, because we're going to need that. We did change some things. So mint to buffer. All right, and that's important for a reason. So these are the seeds, and this isn't going to be owner anymore. This is going to be ctx.accounts.ownervault.mint.key. Perfect. So we're going to have to do the IDL thing again. No, we won't. Okay, so now we add this mint in there. And then there's one other place we need to put this, and that's actually going to be here. It's going to be here. So we're going to put our seeds in here as well. And this is going to be Diamond Hands to account. And that's actually, we want owner to account info as ref. And then we're going to want owner vault dot mint dot key dot as ref. And this is going to be Diamond Hands nonce. And key. All right, so basically we're going to be rederiving and just check that that is the correct answer. I don't think we actually have to do this. We could just do if Diamond Hands equals, oh yeah, we should do this. All right, so there we go. So that, I don't think that changes things either. It's just a check on their side. So that should all be good. Anchor deploy. And we have this Diamond Hands account. So now it's based off of your wallet address and the actual mint of the NFT. Index TS tests. So now this is going to be so we're going to have to actually create the NFT first, which we probably should have done anyway. nft.mint. There we go. So now, if we go to this again, and we see our params, create downhand params, we'll see that we have this now, and that's going to be DHA nonce. And we shouldn't need anything else. And this is where we may run into problems, is we don't have it to sign. We'll see if that's an issue. What is this yelling at? DHA, and then DHA. So now we should be able to have multiple Diamond Hands accounts for basically each NFT or token account that we want to do. So if you can think about it, like this is just a wrapper over a token account to basically say like, hey, we can't do anything with this until a certain time period is up. And again, this should fail here, and that's fine because we had changed back the time, the mint time, and we'll see if it takes. All right, signature verification failed. Okay, so this is kind of what I was afraid of. So if you use this init function, you actually need to pass this guy in as a signer. And since we're deriving this address, we can't pass it in a signer. Don't worry too much because there's a way around that. And basically, it's just saying, okay, well, we need to create the account ahead of time, and we can sign for it ourselves. So let's see. Flipper account. And I'm just checking create. Oh. Aha. God, I love Anchor. I don't know if, yeah, you can only see half the page. Probably shouldn't do that to you. All right. But have no fear, we can actually do this and pass it in the seeds and the bump, which is this. This is going to be Diamond Hands nonce. So I guess bump would be a better term for that. And then seeds, this is going to be owner, and this is going to be owner vault.mint. So that all matches. So we're going to do anchor test again, which is going to compile everything for us, and we're going to see if that does that. And with those seeds, it should sign for us. So, and then we're going to wrap it up right on the dot if everything goes well. All right. Those last little things, and then if this all goes well, we're going to go ahead and end the stream, and then next week we are going to be taking a look at actually writing the API and then hopefully get to a little bit of our front end work to see this actually in action. See how you could like actually use this program. Signature verification failed. All right. Let's just check one more thing. Coin flip. Create. Create flipper winning vault. Interesting. We're going to go ahead and see DHA and DHA nonce. So we're going to go ahead console.log DHA.toString. And DHA dot just nonce. And is find program address the right thing to be calling here? I believe it is. Find flipper. Account. Yep, that should work. Gonna go ahead and print that out. Getting gatekeeper, getting DHA, NFT mint, provider wallet public key, correct? Seeds owner, owner vault.mint, find Diamond Hands account, owner mint, Diamond Hands ID. That's probably, yes. So params.diamondhands and then this, there we go. I was doing that wrong. So with any luck. And that's kind of where some of this gets a little tedious is, you know, you can stare at this code and like sometimes one thing will break and it's not always super clear how, and it's usually some amount of fat fingering something. But I'm relatively confident this is going to work. And again, dying should fail. All right, let's see. Simon says, survey says. I have a signer here. Owner vault. Enter key. Maybe I'm going to learn something today. We'll upgrade that anyway. Just to make sure. Diamond hands, DHA nonce, DHA. Const. Yeah, getting DHA, find Diamond Hands account, provider NFT.mint. Public key, NFT.mint. That should work. And if not, we can figure it out next time too. It's a good problem to start on. And I'll probably have it solved and be able to tell you guys what it is. But I'm going on 12 hours of coding. I should probably get some rest. The only other thing I can think of is, I could signers. Oh, that worked. Hooray. We did it. Okay. Yeah, so we were right. It did work, which is great because now we can rederive from our mint and our actual wallet address. And the reason it failed the first two times is because I didn't update the IDL, I don't believe, or it didn't take some update. That happens every once in a while. So if you think something's wrong, go ahead and update the IDL. Or when you're debugging, stop using the IDL and just use the Anchor environment or workplace. I don't, because I like to have everything as production ready as possible as I'm testing. Because moving out of a testing environment, I want this test to kind of echo and be able to pull a lot of this code into my actual website or wherever I'm using this script. But cool, yeah, that was it. We need to freeze our assets for at least 100 hours. Right. So plus 60 times 60 times 200. And then what's going to happen is it's going to create the account, owner vault, filter keep. So if you guys don't have any more questions, we're going to wrap it up there. So yeah, pretty interesting. We got the entire program done today. We got it to do what we wanted to. We were able to freeze and unfreeze assets. And now we have the added ability to actually be able to rederive our Diamond Hands account from the actual NFT mint, which is always available when you can choose which mint or which NFT you want to actually do. And then we also got this thing to run. So yeah, next time we're going to hit the hit more of the front end. We're going to start actually creating out our API to make this easy for people to call on the front end. And then the last little piece of this before we go on to a new project is going to be creating a little front end to actually save some NFTs. So super cool. We figured it out, and hopefully this was helpful. So, all right, we will catch you guys next week. Adios.